In this question, we have the vector equation of a line given, vector equation of L1. And we know that 2 points lie on this particular line and we have to find the value of the constants. First of all, let me define once more what does it mean that L1 has vector equation. What does that mean? Think of this. If you have a line and suppose this is a point and this point is something, let me call this point x1, y1, z1, and suppose you know that this point, the line that passes to this point, it is also parallel to another vector. Let me call this vector d or d1. Now when they say the vector line L1, the line L1 has vector equation this and that, it simply means that this point over here, 8, 12, 14 is this point, this starting point x1, y1, z1, and this value over here, the direction vector, it is this one, the direction vector d1, and the line is basically an arbitrary point, any point. Let me call that arbitrary point x, and its position vector, let me call that position vector OX, is given by R. That is the vector equation of L1. So L1 is basically this, an arbitrary position vector. You can call this a universal position vector, and it is solved using the basic rule of vector triangle. So if you have a triangle like this, so this is O, let me call this point, let me call this A. So OA plus, we don't know how long this line is, but we know they have the same direction vector d1. That means we can figure out the vector AX by multiplying it with any arbitrary constant lambda, or we can use mu, with the direction vector d1. So the total rule of the vector would be OX equals to OA, that's the clockwise direction, plus AX. That means OA plus lambda of the direction vector. So this is what R is. R is a universal position vector. Now the position of this point x depends on how far it is away from the initial point, which we are calling it A over here, how far it is. That means the longer it is, the value of lambda would be changing, it would be increasing. So for a particular point, the value of lambda is fixed. So suppose if lambda equals to 1, the point might be here. If lambda, and the position vector would be here, and lambda equals to 2, lambda equals to 3, lambda equals to 4, and on it goes on. And for a particular point, the value of lambda for every coordinate is fixed. So that's how this is working. So we can get back to this question. So the first thing is, let's write out the universal position vector, this one, in the IJK format. So this is going to be 8 plus lambda I, 12j plus lambda j, 12 plus lambda j, then 14 minus lambda k. So this is the universal position vector. So what this means basically is that we have some sort of a line where this is the position vector, suppose OX, and this line passes through the point 8, 12, 14. This is the point 8, 12, 14, and it is parallel to a line whose direction vector is I plus j minus k. That means this line, let me call this point W. So this point Wx would depend on this direction vector multiplied by some constant. So we will know how long this line actually is. So this is a universal position vector. When they say point A lies on this line, that means they're actually giving a new position. They're saying, so there is a point A over here, and they're giving us the coordinates of that point. That means we can write OA equals to 4i plus 8j plus ak. Now if this point is a universal position vector, and this is a specific position vector for the point. So we know the value of lambda would be specific. The value of lambda would be the same for each and every coordinate. So we know this. So what we can do, we can equate the two vectors. So we can just write for I equals to I, we can write 8 plus lambda equals to 4, therefore lambda equals to minus 4. Done. We can also do the same with j equals to j. 12 plus lambda equals to 8, therefore lambda equals to minus 4. But we know that lambda is already equals to minus 4, and we want to find the value of the constant a. So now we can do for k equals to k. So this is going to be 14 minus lambda, and we already know lambda is minus 4, and this is equals to a. So a would be equals to 18, therefore a equals to 18. Done. Again, now we have to work with OB. So, and OB. So OB is BI plus 13J plus 13K. So we can write for, now since I is unknown, the coefficient of I is unknown, we're going to start with J. So let's start with J equals to J. In that case, the coefficient of J is 12 plus lambda. This is equals to 13, therefore lambda equals to 1. That means even for k, the lambda is going to be 1. 14 minus lambda equals to 13, therefore lambda would also be equals to 1, because for a particular point, the value of lambda is fixed for that particular point. So now we can compare I. For I equals to I, we can write 8 plus lambda, 8 plus lambda is 1, equals to coefficient of I here is b. That means, therefore, b equals to 9. So we have found the values of a and b. So answer, a equals to 18, b equals to 9. And the next question, this is a bit irregular, so you have to remember how this particular question is done. What we know right now is the universal position vector. So L1 is basically a universal position vector. You know what that is. And if we write, this is L1. So this is a universal position vector. Now they're talking about another point P. So we don't know what that is. And they're saying the point P is such that the position vector is 90 degree to the line L1. That's what it says. Given that the point O is the origin and the point P lies on L1 such that OP is perpendicular to L1, it's 90 degree. It's important to note this special rule. When you have two lines perpendicular, so this is the perpendicular line rule. If you have two lines perpendicular, then direction vector dot direction vector of the other line is always 0. If two lines are perpendicular, then the dot product of the direction vector is 0. So this is very important, and we are going to use this rule. So the dot product of the direction vectors, that's equal to 0. Now, how do we do this sum? First of all, the universal position vector L1 is given by this. Let me copy it. So what does this mean? This means this is the universal position vector, or any point that lies on the line L1 has this position vector, meaning OP is also equal to this. So this is also the same as OP. So we can call this any unknown position vector including OP. So we can just use this as OP. Remember that. If we can use this as OP, then what do we need next? We need to know the value of lambda. For a particular value of lambda, we can find the point P. So the dot product should be with the direction vector. So the direction vector OP is OP itself. So this is OP. Let me write this in the column vector format. It's easier to write. So OP should be 8 plus lambda, 12 plus lambda, 14 minus lambda, dot. Now the direction vector of L1. If you remember, the direction vector of L1 is what is written after the scalar quantity. So this is lambda. Whatever is written here, that's the direction vector. That's the vector with which this is parallel to. So the direction vector of L1 is going to be I plus j minus k. So this is going to be I meaning 1, j meaning 1, minus k meaning minus 1. That's what it is. And this dot product should be equals to 0. So let's do the dot product. So dot product is coefficient of I multiplied by coefficient of I. So that should be 8 plus lambda multiplied by 1 plus coefficient of j multiplied by coefficient of j, 12 plus lambda multiplied by 1 plus coefficient of k, 4 minus lambda multiplied by coefficient of k equals to 0. And this turns out to be 8 plus lambda plus 12 plus lambda minus 14 minus minus plus lambda equals to 0. And we can write lambda plus lambda is 3 lambda. 8 plus 12 is 20. 20 minus 14 is 6. So 3 lambda plus 6 equals to 0. Therefore, lambda equals to minus 2. So for the point P, lambda equals to minus 2. So let's find the value of the coordinates. At lambda equals to minus 2, so we can find OP. OP equals to 8 plus lambda. That means 8 minus 2 is 6i. 12 plus lambda, 12 minus 2 is 10j. And 14 minus lambda, 14 minus minus 2 is plus 16k. So P has coordinates 6, 10, 16. Question number C is just find the length of OP. That means the modulus of the position vector. So question number C would be OP modulus equals to square root of coefficient of I whole square 6 square plus j whole square 10 square plus coefficient of k whole square 16 square, and it turns out to be square root of 36 plus 100 plus 256 equals to, so 100 plus 36 is 136 plus 256, that is 392. Now how to find this in the SERT format? So if we divide this with 2, we get 190, and 14 square is 196. So this is going to be 14 square into 2, 14 square root 2.